Okay, 7.8, inverse functions and relations. I'm not even going to write this out. It says inverse relation. A set of ordered pairs obtained by switching the coordinates of the original ordered pair. That's how you get an inverse relationship. We've done this before. So let's look at number 1. It gives you the ordered pairs of 1, 3, 5, 3, 5, 0, and 1, 0. So let's graph them first, okay? So we're going to graph the original. They call it the pre-image. Okay, so we're going to graph them. I think they're all above that. Oh, wow. I'm really having a hard time keeping my hands steady today. All right, so let's do green for this. 1, 3, 5, 3. Oh, yeah. 1, 2, 3, 4, 5. 1, 2, 3. And then 5, 0 is here. And then 1, 0 is here. And if we connected them, we have a nice rectangle. Now let's do the inverses. Well, if we're doing the inverse of an ordered pair, we just switch the order. So the first one will be 3, 1. The next one will be 3, 5. We're just switching the order. 0, 5, and 0, 1. That's how we figure out the inverse. So 3, 1, 3, 5, 0, 5, and 0, 1. Whoops. I just did that really wrong. Getting tired. Sorry. 0, 5 would be here. I hope some of you knew what I just messed up. I've been recording all day. Can you tell? And then the other one is 1, 0. Jeez. And then if we connect that. So they're inverse images. We have one image and then the inverse. Okay? So that's how you do the inverse of ordered pairs. So that's number 1. Number 2. Oh, don't tell me I'm out of space here. Oh, no, I'm not. Okay, just adding. Number 2. If f and f of 1 are inverse functions, so f and f of negative means they're inverse. Okay, that's just inverses. That's how we note it. And f of a equals b, then we can say f of a equals b if and only if the inverse is f of b, inverse of b equals a. Here's the steps. Number 1, switch the x and y, just like you did above. So in the equation, you're just going to switch the x and y. Number 2, I love this, solve for y. That's it. That's how we find inverses. So that's what all that means. Switch the x and y, solve for y. So let's do number 2. I should have put space between that. F of x equals negative 1/2 x plus 1. Well, the first thing I'm going to do is I'm going to change out my f of x and make that a y. This is what I have. Now I'm going to do my steps. Just like I did in number 1, I'm going to switch my x and y, but this time we're talking about variables. So now my new equation is x equals negative 1/2 y plus 1. And now I solve for y. So I subtract 1 from both sides. X minus 1 equals negative 1/2 x. I'm sorry, 1/2 y. So I'm going to multiply both sides. I'm going to get rid of the negative at the same time. So I'm going to multiply by negative 2 on both sides. Okay, so I have negative 2x plus 2 equals y. And there's my inverse. Okay, so that's the inverse of y equals negative 1/2 x plus 1. I forgot already. So these are inverses. Okay, that's all you do. Let's go to the next side. We're going to do the same thing for number 3. Number 3, let's just do that. Oh, I want to know if these are inverses. So there's 2 ways you can do this. You can do f of g of x and then g of f of x. And if they're the same, if they both equal x, then we're good. But really, I'm going to do the shortcut what we just did. I'm going to take f of x, I'm going to find its inverse, and if it equals g of x, then I know g of x and f of x are inverses. So all I'm going to do is test it. I'm going to do the inverse of f of x. And I'm going to see, does this inverse equal g of x? Well, g of x equals 4/3 x plus 8. So it's really just testing. This is much easier than doing the compositions. Okay, I think this is shorter, and that's how most of us teach it. So y equals 3/4 x minus 6. Let's reverse our x and y. So x equals 3/4 y plus 6. And now we're going to solve for y and see if that equals g of x. Okay, so subtract 6, subtract 6. X minus 6 equals 3/4 y. You could do this a couple ways. You could multiply everything by 4 and then divide by 3, or you can do the reciprocal on both sides, which is faster, so that's what I'm going to do. You could do it either way. You could do it in 2 steps or the reciprocal. So this is 4/3 x minus 24/3 equals y. But 24/3 equals 8, so I'm going to put 8 there. Is this the same as g of x? Yes, it is. Therefore, they are inverses. So yes, inverses. So we just test one and see if it equals the other. If it's true, then they're inverses. Okay? And that's all I'm going to do on this. You can do number 4 on your own if you want and check it with me, or I might have time to do